AP problem number 8. In aqueous solution, ammonia reacts as represented above. In 0.018 molarity NH3 at 25 degrees Celsius, the hydroxide ion concentration OH is 5.60 times 10 to the negative 4 molarity. In answering the following, assume that temperature is constant at 25 degrees Celsius and the volumes are additive. A. Write the equilibrium constant equation for the reaction represented above. For that, you're going to put the concentrations of the products over the reactants. That equals to the concentration of NH4 plus times the concentration of OH minus divided by the concentration of NH3. We do not put the concentration of H2O because that is a liquid. Now for the B, determine the pH of 0.018 molarity of NH3. We know the OH, which is 5.6 times 10 to the negative 4. We can put that in the equation right here, negative log of the OH, and that will equal to 3.25. Now, if we know one, then we can know the other by doing 14 minus POH to get that pH. So it's 14 minus 3.25, and that will equal to the pH 10.75. Now C. Determine the value of the base ionization constant Kb of NH3. For the Kb, we just have to write the equilibrium constant equation with the numbers plugged in. NH4 plus and OH are going to be the same number. And we know OH is 5.6 times 10 to the negative 4. So we can just square it. And then we know that NH3 is 0.018. But if you do the ice, it's 0.018 minus 5.6 times 10 to the negative 4. Although we can see that it's a really small number, and we can just ignore that. And so it's going to be 5.6 times 10 to the negative 4 squared divided by 0.018, and that will equal to 1.74 times 10 to the negative 5, and that is going to be our Kb. Now for D, determine the percent ionization of NH3 in 0.018 NH3. Now for that one, we just have to put the concentration of OH, which is 5.6 times 10 to the negative 4, divided by the concentration of our NH3, which is 0.018 times 100, and that will equal to the 3.11%.